Hello everyone. So in this video we will talk about how we can use Qdrant in offline multimodal searches where no server is required. Okay. So as you can see on the screen, there is a splitted screen where one side is how we use Qdrant before and one side has how we will use Qdrant now. So this is how you normally start with a vector database. There we can see spinning up a server. Wait for it, keep it running in the background. But what if your vector search needed zero servers, zero network calls, and could run entirely on your laptop? Okay, so that's Quadrant Edge, and let's build a real multimodal product search engine with it that is completely offline in the next few minutes. Let's know what Qdrant Edge is. So basically, Qdrant Edge is an embedded in-process vector search engine where no background services are required, minimal memory footprints are used, and uh, you can think of like SQLite but for vector search. It runs directly inside your application and your data lives right there on disk. So now you can see one side is how traditional vector databases work and second side how Quadrant Edge will make it work. In traditional vector database we can see like this is your app in between the cloud and then the Quadrant server where the Docker container is. Okay, so your app will goes to cloud server and then to your Quadrant server takes the data and revert back. But when comes to Quadrant Edge, no such processes will be there. Everything is in your app processes only. So no need to make any other server for that, and that also will increase the timing for the searches. So now let's talk about like why it matters and what multimodal means here. Um, let's take one example like think about a robot navigating a building, a retail kiosk, or a mobile app that needs to work in the subway. These environments can't always rely on a stable connection. And sometimes, for privacy, you don't want the data leaving the device at all. And this isn't just offline search, it's multimodal using clip. Text and images live in the same vector. That means I can describe a product in words and get back matching photos or hand it in a photo and get back a matching text description. All four directions on one device. Now let's see how we can build Quadrant Edge shard on our local PC. So first starting with creating the requirement.txt where we will add Quadrant Edge py and FastEmbed, where Quadrant Edge py gives us the embedded shard and FastEmbed gives us local clip models, so no API keys, nothing to sign up for. Now first let's activate our virtual environment. After activating our virtual environment, let's install the requirements.txt file which contains Quadrant Edge py and FastEmbed. So here you can see the three packages are checked and installed on our local PC: the Quadrant Edge py, FastEmbed, and Rich. So now as we move towards creating the shard, okay, so let's go to search engine.py where we will explore the how we can create Quadrant Edge shard on our local PC. Okay, So here you can see the key designs decision. Every product in our chart gets two. Okay, so named vectors are what we can say, an image vector and a text vector, both with the 512 dimensions, both living in the same clip space. That's what unlocks searching in any direction between text and images. Okay, so yeah, here you can see the shard directory where edge search engine is there, and uh, the two vectors. Okay, the first one is for the image and the second one is for the text. So, and there it is, like, and as we can see in the, so now here we can see the Qdrant Edge storage folder is created in our own personal directory, and in that we can see those segments, the walls, and the edge config. Okay, let's move to building the index. Okay, so here the catalog.json contains the id, the name, the category, and the image, and finally the description of the products which we have in our database. Okay, so our description for each every product, we embed the image with Clips Vision. Model embedded the description with Clips text model and store both vectors on the same point. Okay, and our catalog has 12 products, each with a photo and a short text. So that at the time of searches, it will retract from the database. Now let's see by running the command for building the index. Build underscore index. Okay, and as we run this, we can see those 12 products are indexed into our local shard, and each product has both an image vector and a text vector. So yeah, as we can see, it is running, and here we can see that, yeah, the indexed 12 on 12 products into local shard, and each product has both image and text vector, and the location is also given where it is where we saw the Qdrant Edge Pro folder in our local file directory. Okay, and it is happening totally offline. No Wi-Fi or no network is there on my PC. In text to text part, we will be giving the text as input and also expecting the text as output only. Okay, so here we can see I had done a mistake in that. One sec. Yeah, so you can see we had given the text as input keeps me dry in the rain, and the target which we are expecting is also a text. So yeah, as we can see, the output that first comes is the slate gray rain jacket. Okay, that keeps me dry in rain. So obviously if you want to become like, if you want to be dry in the rain, you will be using rain jacket. Okay, so yeah, it has given with the scores. So the text to text part is also cleared out, that if we give the text, then the output is also in the text if we are expecting the same target. Okay, the text and the text. So till now we had seen image to image, text to text, and text to image. Okay, those three parts are cleared. And now moving to the fourth one, and that is image to text. Okay, so we are giving input as image and we'll be getting the output as text. So now let's move for image for text. So defining the format we want as input image, the folder in which the images are. The image which we are taking is crimson running shoes dot jpg with the extension, and the target which we'll be getting is text. So here we are going with image to text. Okay, yeah. So let's see the output for this. So yeah, as we can see, we had given input as what? Input as image. Okay, the crimson running shoes dot jpg image. Where it is? Here it is. Okay, this image we had given as input, and we are expecting as text the output. As you can see, lightweight red running shoes built for trial terrain with breathable mesh and grip soles. The exact description we had here. Okay, so yeah, it is giving. And also we can see the timings, like the 45.45 milliseconds. Okay, so the timing is also reduced, and it is totally running offline. No form of internet is there in my PC. So till now we had seen all the four stages, all the four parts: the text to image, image to image, text to text, and image to text. So all four, as this shows that multi modes are also now used and can be run offline with the use of Qdrant Edge. So now we had seen all the four modes completely working, and the multi-mode which shows the image to text and text to image part is also working properly fine, as we can see the outputs. See, okay, so and also the timings, and it is happening under a millisecond. Okay, you can see for text to text it's 0.85 milliseconds, for image to text it's 0.45 millisecond. So it is happening so fast, and also offline. So that's a big advantage of Qdrant Edge that will be used. And the final implementation, like how the multimodal works, is the text to image where we describe it. Okay, then image to text we explain it with the help of image, like this text I want. Okay, now when we go for image to image, it finds similar type of images and gives the output. Okay, and when we go for text to text, it matches the wordings which is stored in the database, okay, in the form of vectors. So the text to image, the image to text, the image to image, and the text to text, all four modes are running completely fine, and also all modes are running offline with very less number of time which is required. Okay, so yeah, so that's Qdrant Edge, a fully offline multimodal search engine running entirely on device, searchable in all four directions between text and images. Link to the docs and this code are in description. If you built something with this, I would love to see it. Please drop your work in the comments, and if you found this useful, just like, share, comment, and subscribe, so that we would get to know, and more things we will be bringing now. Thank you.